So I gave a lot of details in the last video about how to graph either the cosecant or the secant. And so what we want to do here is now we see we're going to graph the cosecant. So the first thing we want to do is graph y equals 3 times the sine of, let's do all this at once. Let's factor out a 2. And we get x, and then we want to factor out a 2 from this fraction over here. I go into more detail about how to do that in the second and third videos on how to factor out a 2. So we want to get it in the form a times sine of b times x minus something, and that something, after taking the 2 away, would be pi over 6. It would be x plus pi over 6, and then there's no plus anything else on the outside. So getting to this point here, then we find and plot the period. So the period would be 2 pi over b. b is 2, so the period is pi. So we want to find and plot that. And I'm going to get rid of that so I have a little bit more space. So we're going to find and plot that. Let's plot it. Let's draw the graph down here. And so the period being pi, we're ultimately going to be shifting the graph to the left pi over 6 radians. So we're going to leave a little space here. And we're going to put pi right there. Cut that in half and we get pi over 2. Halfway between 0 and pi over 2 is pi over 4. And then halfway between pi over 2 and pi is 3 pi over 4. So we have our period sectioned off into 4 equal sections, and then we're going to draw the midline, which there's no shifting up or down, so the midline is y equals 0. Find and labeling the amplitude. Now the amplitude for this function is a 3. Okay, so the amplitude is the absolute value of 3, which is 3. So we're going to mark that on the y-axis. 3 there and negative 3 there. So 3 units away from the midline. And now we're going to draw the sinusoidal graph without the shift left or right. So we know it's a sine, and so we start the sine always at the origin, and then we go up to that point, back down to the midline, down to the low point, and back up to the midline. So up to there, down. This is without the shift, so there's 2 different dashed curves that we're going to be drawing here before we ultimately get to the cosecant graph. Then we're going to shift this dashed curve to the left pi over 6 radians. So this is kind of the tricky part, and pi over 6 radians to the left, if you think about the unit circle, if pi over 4 is there, we talked about this in an earlier video. So if we think about pi over 4 and how that relates, so if pi over 4 is the halfway point between 0 and pi over 2, and pi over 6 then would be 2/3 of the way to pi over 4. Okay, if you think about it in terms of every 15 degrees, 15, 30, 45, and then 60, 75, and 90. So if we break up that first quadrant into 1, 2, 3, 4, 5, 6 equal sections, it takes 2 sections to get over there to that pi over 6 angle, 3 sections to get all the way to the pi over 4. So in other words, if we divide each of these subsections into 3 equal parts, then we can better figure out where those pi over 6 angles should be, those real numbers, I should say, pi over 6. So this is negative pi over 4. So if we're going to shift this whole graph to the left pi over 6, then this point would 2/3, my bad. So 2/3 of the way, negative pi over 6 would be 1, 2 right there. And then this point would go over 1, 2 pi over 6's. So that would be 2 sections, 2/3 of the way to the left. And then we have this point here, which moves to the left 2 sections. And then each point moves to the left 2/3 of the way to the next real number that's listed here. And same with this guy here, 1, 2. So now we have, let's do this one in red. Now we have the graph of y equals 3 times the sine of 2 times the quantity x plus pi over 6. So it comes down like this, and it goes up to that point right there. So the red dotted line, red dotted curve, is the graph of y equals the 3 times the sine of 2 times x plus pi over 6. Now that we have that graph, we can move to graphing the 3 times the cosecant. Because all we have to do with the cosecant is draw a vertical asymptote where the sine graph is equal to 0, because the cosecant graph doesn't exist. Cosecant function doesn't exist where the sine is equal to 0. So we're going to draw an asymptote at the negative pi over 6 angle, and this angle here, and then we need to figure out what that angle is right there, because we have an asymptote there and we need to figure that out. So how do we do that? Well, we took, to get to here, to get to this point here, we took pi and we subtracted pi over 6, because 2 of these little sections is pi over 6 radians. So pi minus pi over 6 is 6 pi over 6 minus 1 pi over 6, which is 5 pi over 6. That's just the 5 pi over 6 angle. Okay, 5 pi over 6. And then pi over 2 minus pi over 6 would be your pi over 3 angle. So do the math and you get pi over 3. So we have negative pi over 6, pi over 3, and 5 pi over 6 where the asymptotes are on the graph of the cosecant. And then, remember, the cosecant, how it relates to the sine. The high point on the sine is the low point on the cosecant. And then you just, from the low point, you approach both asymptotes. From the high point, the low point on the sine or the high point on the cosecant, you approach those vertical asymptotes, just like we did when we graphed the secant from the cosine graph.